In this video, we're going to cover the calculations for a weak acid strong base titration where we have passed the equivalence point. So as we can see, just like our previous videos, we have 25 milliliters of 0.1 acetic acid, which we will abbreviate as HA, and we're titrating with sodium hydroxide, which will have 37 milliliters of this time. Okay, so first let's just write out the reaction for our fake rice table so that we can handle our stoichiometry. We know that our weak acid and strong base equation will produce the conjugate base of our weak acid, who is acetate in this case, and some water. Okay. Now we just need to calculate our moles, so we'll do 0.1 multiplied by 0.025 liters, which will get us 0.0025 moles. And then we will multiply our 0.1 times 0.037 liters, which will get us 0.0037. Now, what makes this particular process different than the other videos is that this time our weak acid is our limiting reactant. So we will subtract all of the moles of the weak acid and then we'll do a quick calculation to subtract for the hydroxide. 0.0037 minus 0.0025. And now we can see what our new totals are going to be. When we set up our rice table for the second part of the equation, everything's going to be a little different. This time in our bucket, we have significant quantities of hydroxide, who generally will control pH at this point in a titration, and the weak base. So now, if we want to, we can set up our rice table for the reaction that you would at the equivalence point, where we have our weak base. That weak base could attack some water to make some more hydroxide and weak acid. But our starting amounts are going to be a little bit different. Let's go ahead and take those mole amounts that we had in the previous question of our hydroxide, which was 0.0012, and divide it by our total volume amount. Right now that's 25 milliliters plus 37 milliliters. Divide it by 1,000 to get 0.062. Again, this was the moles of the hydroxide and the liters of solution. So I'll do my 0.0012 divided by 0.062 to get 0.019-ish molarity. You can keep the rest of the digits if you want until the end. And then for my weak base, the conjugate base of my weak acid, acetate in this case, we had 0.0025 moles of that stuff, and we'll divide it by the same amount of liters to get 0.040 molarity. Now, if you were to set up this rice table, we actually don't have to fill out the whole thing. At this point, we would assume that we didn't have any weak acid because it was all titrated. And then you could set up your minus X and your plus X. But honestly, what would be the purpose of finding X? Our K value for acetate, the Kb, is so small, 5.6 times 10 to the negative 10, that any change in X is going to be insignificant, or rather really, really small. So my hydroxide amount, the part that's actually controlling pH at this point in the titration, is just not going to change. So we can skip doing the calculations to find X and just go ahead and find the pOH by using the negative log of the hydroxide concentration. So I'm going to go ahead and plug that in a calculator. Negative log of 0.019. I'm going to use the stored value in my calculator, and then we'll round afterwards. And we have a pOH at this point of 1.713, which is honestly, that makes a lot of sense because we have totally gotten rid of all of our weak acid. We're going to have a very high pH. I'll do 14 minus that number to get the pH of 12.287. And that is how you handle pH calculations for a titration problem if you have passed the equivalence point.